This video is an introduction to the concept of databases and how to use them in Thunkable. So up to this point in the Thunkable course, we've used apps that have only used fixed data, otherwise known as static data. So what you're looking at right here is an example of the slideshow app. And you'll notice that all the important values and information, the data that flows through this app is already set. We hard coded it directly into the app, and it doesn't change on the basis of who the user is. It's always the same. We were able to get a little more sophisticated with it as we introduced the concept of lists, which allowed us to keep a lot of our code consistent and using the list to start to change the data that goes through. But even in this case, this data is still fixed. It's static. It doesn't change on the basis of who the user is. And so we need to, or the next level in our understanding of our basic computer science concepts is introduction of databases, because they allow us to create much more dynamic apps. And dynamic apps, as opposed to fixed data, is information either input by the user or loaded in from an information source, be generated as the app runs. So for example, the score is recorded from playing a game. This data generally is, or up to this point, the data would be stored temporarily in the variables that we create. But if we start to add databases, which are sets of data that can be stored on your computer or perhaps in the cloud, you can then store it such that, or essentially save it so that it can be accessed at other times that you are interacting with that. So in this video, very simply, we'll go over three main topics: transient versus persistent data, user-generated data, and how to use databases in Thunkable. So in short, if you're thinking about these two concepts, transient data versus persistent data, transient data is data that is temporary. It's essentially like short-term memory. It's created in like one use of an app, and when you close the app or you shut down your program, that information goes away. It's not stored anywhere. It doesn't, for example, doesn't get stored in any sort of long-term memory. So the data is temporary and it's lost when you restart the program. The idea of persistent data is the idea that you can have data that exists from session to session when you're using an app or a program. It's generally stored in a database, which again can be on your computer or up in the cloud, which are servers that you access through the internet rather than existing in a physical location. And this data will be lasting. It'll be there when you restart the program, or it'll be there as long as you have access to that data and doesn't go away. Here are some basic examples of how one might encounter data on sort of a day-to-day basis, and we'll go through whether they're transient or persistent. So if you have had to use a calculator anytime in the past, probably a calculator hasn't changed much in the last 40 or 50 years. You put in a couple numbers, you do an operation such as addition or subtraction or multiplication, and the moment you clear it, that information goes away, or that data goes away. And so the data on a calculator generally is what we would consider to be transient. If you're playing a video game and you get a high score and you put your name in and you have a feeling that high score, because it's being compared to all the other scores, is being saved for a long period of time, it's very likely we can consider that data to be persistent. If you are playing a video game and there's a health meter for a character and you encounter a villain sprite of some sort who damages your character and your health meter goes down, but if you reset the game, the health meter would go back to its beginning place. We might consider that data to be transient because it's short term, it doesn't stay. If you enter information on a Facebook page, whether that's a comment or you're adding a photo, somewhat frighteningly, that information is persistent. It goes into Facebook's server. They would legally claim that they now own that information, even if it's your picture or your comment, and it may exist forever, maybe unfortunately. If you're downloading a song onto iTunes or your hard drive, which I guess people don't do as much anymore with Spotify, but imagine that you did back in the olden days, and you had access to that song, and you could play it over and over again. It doesn't go anywhere. You can consider that to be persistent. If you're playing a video on YouTube, even if you can refresh it and play again, you've sort of streamed that data and downloaded, and that specific data is meant to be used, or in that form, it's meant to be used once. If you close YouTube, you may go back to that starting point, or maybe halfway through the video, but even in that case, we would not consider it to be persistent. It won't last forever. It's a data that you're using in that one session. Generally, though there are some exceptions. Alrighty. The reason why databases are so important and being able to use data generally is that it makes our apps much more dynamic. And to be more specific about that, what that means is instead of just being apps that don't change depending on the user, you can start to make them much more specific to the user. You can really start to modify the user experience because the apps are now collecting data from your user. So most real apps that you use outside of this course, probably already on your devices, they revolve really around user-generated data. You probably have shared a lot of data through social networks and perhaps interactive games. A very basic data that should be private to you but is still persistent would be things like usernames and passwords. Any preferences, like when you have like autocorrect in some word processing programs, or whenever you like start to type in a URL up in your browser search bar and it finishes it for you. They've stored data there, and that's your data, and they also are collecting that data. So importantly, this is the distinction I was trying to make with the slideshow app. The data from the app is not fixed, so you don't see it as part of the code itself. So you have the code, but you won't, if you looked under the hood, you're not going to see a list specifically within the app that like has your username and password, or it's not going to show all the images that you want to come up with in an app. That is stored in a database. So again, the slideshow, the images were directly coded into the app. This video is an introduction to databases, but the next app you're actually going to build is the Note Taker app, and that will store data directly in a database. Connecting user-generated data to the idea of persistence. We're generally considering user-generated data. It's entered by the user. It's going to be there when a user closes the app and reopens it, and it's going to be stored in a database. So you can connect those ideas, user-generated data. For better or for worse, you can expect there's going to be persistence, and your data is going to be saved. Generally, if we're just talking about databases, they're sets of data that are held digitally, and they're accessible in many different types of ways. So examples of databases, I suppose, would be in Facebook. It's got a list of your friends and list of their status updates and other things. You might have a game has a list of characters or all-time high scores that may be stored in some sort of database, especially if you're playing the game online. We have built a quiz app in this course, and we have hard-coded it, such as the questions and answers are locked into the app, but in theory we could also store those in a database. With Thunkable, there are two main components that we will be using. One is very simple. It's called a local storage component. It's a database which stores the user-generated data directly on the phone or tablet. In our case, because we're often testing the apps in the browser, it's actually storing directly as data that's connected to the app project. So it's actually not on the phone or tablet. I suppose it would be on Thunkable's servers, which we could consider to be the cloud, because they are. It's probably not being saved locally. But if you actually downloaded the Thunkable apps as a specific app that you put on your phone, then in that case it would store your phone or tablet. And you might use this where you're storing database on the phone or tablet with apps that have like data that's private to you. So if you're, say, tracking your workouts or tracking your diet, or you have some sort of note-taking app where you just want to information that should be private to you, more specifically, that can use a database, or the local storage component would be appropriate for that. Thunkable also has something called a real-time DB component, which stores user-generated data in the cloud. Again, the cloud is sort of a contemporary term which really just refers to these huge servers that companies like Amazon have set up that store a lot of information for you that you can access via the internet. And the reason why that's important is because sometimes, I mean, you probably experience that on a local level when you're going through, say, something like Google Sheets, and you put enough information in there, a couple hundred rows of things, and it's a lot of data, and it's hard to access it, and it's hard to get it to load and run, and it's hard to work with it. So you can imagine how much room it's taking up just on your hard drive. And that's why the idea of the cloud, being able to store data in server farms, which quite often are near the North Pole now because server farms they generate so much heat that it's much cool. They're built in areas that are much cooler because then it takes a lot less power to cool them down. That's an aside. Anyway, Thunkable has the real-time DB component, and you might have interacted like that with similar sort of database components like all the time. Whenever you're using a social app, even when you're just using Messenger on your phone or you're just texting people, that information is being stored every time you're able to pull it up. If you have an iPhone and you use iCloud and you switched from one, like you upgraded your phone and maybe you passed a data chip between them, but maybe you didn't. Maybe they just uploaded all your old data from iCloud because it's constantly uploading to that server. And so basically just consider that data will persist between the uses of the app using any of those components, even if you close the app. So another topic, how do databases actually store values? So a very, very common form of storing a value in a database is something you would call a key value pair. So an example of a key value pair might be like the key, which is the reference or sort of the index for which you would find all the values. It's like the location or the address. So if we had a key, it was called username, and the associated values, it could be just one, it could have just been my name, Andrew, or it could be a lot of names like Andrew and Taylor and Eli and Scott and Allison or whoever else. You can have more than one value associated with the username, but they're generally stored together. And then, so again, a key is like an index variable. It's an address that gives location where a piece of data is stored, and you need to create a key for each piece of data that you are storing. So, and that is very specific because when you want to retrieve the data, you need that address, you need that key. So you'll enter the key, and a time that you're actually doing this, and you may not have realized this, anytime you're using hashtags on social media, the hashtag is the key that is then when you search, obviously, for that hashtag, all the values associated with that hashtag are accessible. So that's a time when you may not have realized it, but you're using keys and values. I'm going to show you a quick example of what this might look like entering keys and values. And this is really basic, but you get the idea how easy it would be to collect information on a larger scale and what that might look like. So if I just have like a basic form here, I've set this up in Google Forms, and I just want to get some information. So we just use an example. We can use the same one. So I'm going to call this key usernames, and the values that I'll put toward this username is just a bunch of generic names. So Andrew and Allison and Scott and Lisa and Neil and Tina. These are all the values that I want to store in a database, and I'm storing them on the basis of a key value pair. So I'm going to submit this information, and that's sort of just my entry point here. But I have a database here that I set up, which is this sheet, which is like sort of a very simple form of a database. And you can see that under the key, I have the usernames, and under the values, everything that I just typed in. And on this basis, if I was trying to locate this information, all the values that I just put in, if I was going to search for them, I would search for them by the key, in this case, username. So you can imagine if I had a big list here of a lot of different keys and a lot of different values, it'd be valuable information, obviously, but how I would find it would be through the key. And so going forward, you guys are going to build hopefully at least one, if not more than one, apps that utilize the database. And I'll just end by saying databases are considered a relatively advanced programming technique. We're going to be able to do some pretty nifty stuff in Thunkable, but they generally require setting up like a fair amount of setup to get a database set up, whether it's on your own personal server or up on a cloud server. There's a different code language which interfaces with database. It's called SQL, or referenced as SQL. We won't have to do that, but it's not a bad skill to pick up. And generally in university level, database programming isn't taught till generally upper division courses. So it's considered like a fundamental part of software engineering or sort of database management. And we're going to get to do it here in CS 107. So thanks for watching, and good luck using databases on your apps going forward.